function and wants us to figure out the relative min and relative maximum for this function. So, what would be the absolute fastest way to do this if you just had to have the answer to this? Right. If you had a calculator, I would probably just graph it and look for the max and the min. But 99% chance this would be on the no calculator part. So you could either do first derivative test or second derivative test. So I'm going to do first derivative test because it always works, but second derivative test is also important and tested. So first derivative test says find your critical numbers, which is when the first derivative is 0 or undefined. So we got to be able to define the first derivative using the power rule a couple times. Factor, I guess you don't have to factor out that GCF, but it makes the rest a little bit easier. So we have critical numbers at x equals 1 and critical number at x equals -2. And a critical number is where it is probably changing directions. No guarantee, but probably. So if you want to use the second derivative test, you're actually going to plug these numbers into the second derivative, figure out if it's concave up or concave down. If it's concave down, it's a min. If it's concave up, it's a max. Again, I'm just going to stick with the first derivative test. So I'm going to test like 0, and I'm going to plug that into the first derivative and see that I get something negative. So I know the graph is decreasing then. Maybe plug in something like 2 into the first derivative. Now, sometimes when you guys have the first derivative written out in multiple forms like this, you should be picky about what to plug it into. I mean, you can plug it in up here, but doing 6 times 2 squared plus 6 times 2 minus 12 is a little bit harder arithmetic to do without a calculator. Try plugging it in down here. You would have a positive times a positive times a positive. So I don't know what that number is, but I know it's positive. So to me, it makes more sense to plug it in here than there. And you've got to test around every side of the critical number, so maybe even something like -3. And so if I plug it in here, I have a positive times a negative times a negative, and positive times a negative would be positive, so it's increasing. So I can see that there's a max at x equals 2 and a min at x equals 1, but that's not what the question's asking. It's asking find the relative max and min. So I know when these occur. This one is when x is 1, and this one is when x is -2. But the actual max and min values are the y values. And you would get the y values from plugging in the x value into the function. So f of 1 would be 2 plus 3 minus 12. So -7. And the relative max would be when you plug in -2 into the function. So this would be 2 times -8 plus 3 times 4 minus 12 times -2. So got to be a little more careful with the directions here, but it looks like that should come out to be 20. So that's what I would call the relative max and min, and if I needed it, when they occur. Okay, anything more specific about this one while it's up?